Okay, so today we do the two other forms, which are point slope and standard. And point slope I use quite a bit. The point slope form of a linear equation is this: y minus y1 equals m times x minus x1. I mean, all those are familiar notations for us, right? M represents slope, right? Same slope that we've been dealing with so far. Lowercase m is the slope. And the y minus y1 on the left, x minus x1 on the right. Remember, x1, y1 and x2, y2, those were 2 points that we used to calculate the slope, right? Here we only have 1 point in there, right? So it's x1, y1. That is a fixed point. That's a point you're going to be given, right? The x and the y, those are variables. You're not going to fill in for them. I mean, your final equation, it has to have an x and a y in it, a variable that you can plug in for. So don't confuse which is a variable and which is actually a number that we know. Whenever you use a subscript like sub x1, x2, that's a fixed point, something that we know. And looking at that form, you can kind of understand, where does the name come from? Because what's in it? 1 point and the slope. Point slope form. Or other way around, if somebody tells you the name of it, it should kind of tell you what it is you should be looking for in the equation. A point, and the slope. So write an equation in point slope form that passes through, and there's the given point, and has a slope of, and there's the slope. So if you're given a point and the slope, you should be able to put it into point slope form. So I'm going to write the formula first, and then I'll fill in for the things, right? You have to memorize the formula. Y, I want to do black, I want to do blue. Y minus y1 equals m times x minus x1. So I have to fill in for the point and the slope, right? This is the x1, y1, and this is the m. So y minus negative 2 equals 2 times x minus 4. Now, if you're asked to put it into point slope form, then you should simplify. At least minus a negative should be turned into a plus, right? So I can make that into y plus 2 equals 2 times x minus 4. But that's it. Then you're done. Right? If all you're asked to do is put it in point slope form, that's the point slope form, and you're done. Now, the thing is, and I think some of the homework problems, they don't ask you to take this next step, but we should always then put it in a slope-intercept form from there. So how do I take that equation and put it into slope-intercept form, generally? How do you put an equation into slope-intercept form? 3 words. Generally, solve for y, right? That's how you do it. So in the end, let's solve that for y and then simplify everything that we can. What would you do first? If you were going to solve this for y and simplify, what do you think you would do first? You could subtract the 2 to the other side, right? But that's not simplified. Now what do I have to do? I mean, I'm going to have to combine some like terms. Go ahead. You're going to have to use distributive property, right? 2x minus 8. And then combine like terms. So that is 2x minus 10. So again, that you can't put in the calculator. That you could put in the calculator. Right? So solving for y makes, okay, now this is something I can put in the calculator. You know, if you need help graphing or something like that, then solve for y, put it in the y equation. So my guess is that now you get to do one. So write in point slope form. It doesn't say to solve for y, it just says put it in that point slope form. All right. So what is it? If I just, my first substitution, what is that going to look like? Y minus 4 equals times, yeah, it's x minus a negative 1 or x plus 1. Right? Make sure you always have to change a minus and negative into a positive before you go any further. Okay, now, I know it wasn't part of the you try, but solve for y. Do what we did on the last one. Solve for y. Oh, you did? Good. Let me see. Yeah. Do it? No, I said solve for y now. Do what we did on the other problem. Who's got an answer? You distribute, right? That's negative 2x minus 2. You didn't distribute. Negative 2. Negative 2 times 1 is negative 2. Nope. If you add 4 to both sides, that's a plus 4. How do you cancel a minus 4 on the left? You add 4. How did you get a 4 over here? So what did you do? You added 4 to cancel a minus 4, right? Basic algebra. I can't help you any more than that. You should know that. It's basic algebra. It's day 1. Yeah. That's it. Yeah. Nope. Where did you distribute the negative 2x minus 2? Yeah, it's distributive property. Negative 2 times x. Negative 2 times 1. Come on now. If you don't know distributive property, or if you don't know how to like cancel a minus 4 on one side, there's not much we can do for you here. Yep. Yep. Okay, here we go. Y minus 4 is negative 2x minus 2, right? That's distributive property, right? Day 1, algebra 1. And then how do you cancel a minus 4 on the left so that you isolate the y? You add 4. Add 4. So this is y equals negative 2x plus 2. right? Now you can put it in the calculator. Graph. So if you have something that's in point slope form, you ought to be able to graph it. Because as long as you know one point, right, it's not going to be the y-intercept, but it is a point on the graph, and you know the slope, which is telling you how to go from that point to another point, then there's your 2 points, graph a line. What's the slope of this one? Right, just comparing it to the equation, right, to the formula. Y minus y1 is m times x minus x1. Right, the easy part is that m equals 2/3. Okay, but what is x1, y1? What is the x1? Okay, keep in mind, the formula has a minus in it, right? So when you see x minus 3, that means the x1 is positive 3, right? What happens when your x1 or your y1 is negative? Then you get minus a negative, which is a plus. So when you see a plus, it means that your coordinate must have been a negative because it's minus in front of it. So in this case, it's the x1 is the positive, and the y1 is the negative. Right? Just imagine that you were given these two things and you had to put them into the equation, right? Y minus negative 2 is y plus 2. X minus 3 is x minus 3. So you may have to think of it like it's an opposite sense. Whatever you see in the parentheses, it's the opposite of that because of those minus signs. Okay, now with those two things, let's graph it. 3, negative 2, which quadrant am I in? What do you call that one? Fourth quadrant, right? So it's going to be 3, negative 2, which is 1, 2, 3, fourth quadrant. So plot that point. 3, negative 2. And then the 2 over 3 is telling you what? Up 2 and right 3. So from this point, right, that's not the point 2, 3, and you don't start at the origin. It's from the point you already plotted. Go up 2, right 3. Plot another point. And then draw a line. Right? So it doesn't have to be that you start with the y-intercept. As long as you know one point, plot it, use the slope to find another point.
I like that.
Is Trinity going to be positive now?
Yeah.
Are you waking up?
Mhm.
You know, the place that we're going to make the most mistakes on this is that you're not going to say 3, negative 2, that you'll get the sign of that wrong. And it comes up in a lot of things that we do in math from here on out. And believe me, the students in the higher classes make the same mistakes frequently. But you just have to get it straight. When there's a negative in the formula, right, then seeing the minus in the equation, that actually means you have a positive number. Okay. So graph that one. The slope, when you don't see a number there, it's a 1. And because it's a negative 1. What was the point?
2, 1.
Positive 2, positive 1, right? So it should have looked like that. Right? So that's what first you've got to take out of the equation, and then you're going to plot the points 2, 1, and then use the slope. Negative 1 means negative 1 over positive 1 is down 1, right 1. Draw another point, connect them with a line. Now, some of you, I would bet that if I put that question on the test, that some of you will actually solve for y to put it in slope-intercept form because you're more comfortable graphing like that, which is fine. As long as you do it correctly, that's okay. But you really don't have to, right? Because if you know a point in the slope, you should be able to find the line. Yeah, I mean, you could just like add 1 and then distribute the negative combined like terms, and now you've got it in slope-intercept form. Yep, sure. So now let's see whether we could write the equation, the point-slope form, if we are looking at a graph. So what do we need to plug into the equation? A point and the slope. So those two things you got to pull out of here. Well, let's see. We don't know what the slope is, but we have 2 points. So we could calculate it using the formula. What else could you do? Just look at the graph, right? What does it look like you're doing to go from here to here? It looks like you're going down 2, right 2. What does that make the slope? -2 over +2, which is -1, right? So either use the formula, or if you've got the graph right in front of you, you can just like count how much is it going up and down and left and right. So this one is m equals down 2 divided by right 2, which is -1. Okay, now we need a point, but we got 2 points. So which are we going to use? It does not matter. Now, if it says like this one, write the equation in point-slope form, right? Didn't say solve for y, just said put it in point-slope form. You'll get a different answer if you use one point or the other. And both of them are right in point-slope form. Let me see if what my next slide is. No. All right, so let's say I use the first point, -1, 3. Then I would have y minus 3 equals -1, which is just a negative sign, x plus 1. Right? If I use the other point, I'm going to get clear. Y minus 1 equals -x minus 1. Sorry, I should have put in the 1, 1. So you'll get a different equation depending on which point you use. But if you solve for y, it'll be the same. In the end, this is the same line. So you don't have 2 equations of a line, just a different form. So if I solve this one here, it'll look like this. Right? Y minus 3 equals -x minus 1. Y equals -x plus 2. If I solve this one, y minus 1 equals -x plus 1. If I add 1 to both sides, y equals -x plus 2. So in slope-intercept form, it's the same thing. It won't be the same in point-slope form. So you try. Write an equation in point-slope form that passes through those 2 points. And you don't have a graph, so you just have to calculate the slope. So we all get a slope of 1/2.
I did.
You should have, right? That's been there, done that, got the T-shirt, as they say. Do they still say that?
I never heard that.
You never heard been there, done that, got the T-shirt?
No. I heard been there, done that, but I haven't heard that T-shirt part.
And because it's probably kind of dated now, but you know, like more like in the 80s and that, you'd participate in something and they'd always give you a free T-shirt. Been there, done that, got the T-shirt. So I guess they don't do that anymore, right? Nothing's for free.
You don't get T-shirts.
In those days, because I'd run races, right? And if you run a race, it costs like $5, no big deal. These days you run a race, it's like $100. And everything's like really expensive. You keep all these gifts and stuff like that. Okay. Okay, so now we got to plug that into the formula, right? What is it going to look like? If I use 2, 3, what does it look like?
Y minus 3 equals 1 half times x minus 2.
What if I use 4, 4?
Oh, y minus 4 equals 1 half times x minus 4.
Right? Which look different, and that's okay, right? If you could ask that, I'll check for both, right? If I solve for y minus 3 is 1 half x minus 1, add 3, y equals 1 half x plus 2, right? Y minus 4 equals 1 half x minus 2, add 4, y equals 1 half x plus 2. So it's got to be the same in slope-intercept form. Okay. Should be getting close here. So, you are designing a sticker to advertise your band. A company charges $2.25 for the first 100 stickers and $80 for additional 1,000 stickers. For the what's that? For the first 1,000, okay, and 80 for each additional 1,000 stickers. Write an equation that gives the cost of stickers as a function of the number of stickers. Right, so it's kind of like a problem we did in the last 2 assignments ago, right, where we can either take a point in the slope, or actually it was the one from last assignment, a point in the slope or 2 points, and make an equation of a line. And we didn't use point slope, we used slope intercept to do it. But in this case, what does it look like they gave us? Did they give us 2 points, or did they give us a point in the slope? It looks like it's 2 points, right? Now, is it, for example, here, 225 comma 1,000, or is it 1,000 comma 225?
1,000 comma 225.
Right, they're saying it should be the cost of the stickers is a function of the number of stickers. That means that the x is the number of stickers and the cost is the y. Right, so we have 2 points here. Right, the number 1 point is 1,000. Actually, I'm wrong. Sorry, I told you a wrong thing. Right, that is definitely a point. The next one is not a point, is it? I mean, we already have a 1,225. We don't also have a 1,000 comma 80. What does that actually represent? That's how much it costs for each additional 1,000 stickers, right? So that's actually a slope, right? You get 80. The slope is, this is the x1, y1. And the slope should be $80 per 1,000 is the m. So in the end, we have a point in the slope, and we're doing point slope. So plug it in. Right? It'll look like y minus 225 equals 80 over 1,000 x minus 1,000. So find the cost of 9,000 stickers. So what do we expect it to do with the 9,000?
Plug it in somewhere.
Plug it in for x, right? The x is the number of stickers, so plug in 9,000. Now in the end, what are you going to solve for?
Y.
So y. So it might be a good idea like to solve this for y before you plug in, because that is not solved for y. you would still have to do a little bit of math after plugging it in. So how about if I do that? This is going to be y minus 225 equals 80 over 1,000. What is that? What is that as a simplified fraction? 2 over 25? You do 80 divided by 1,000 and then do math, enter, enter. Not 80 over 100, 80 over 1,000. I want a fraction. 2 over 25. Now, when I multiply 80 over 1,000 times 1,000, what do I get? 80 over 1,000 times 1,000. You shouldn't need a calculator for that. 80. The thousands cancel. Okay? And now, add 225. What is 2/25 times x? What is negative 80 plus 225? Plus. Negative 80 plus 225. 145? Okay. Okay, so now, using that equation, plug in 9,000. So now take the 9,000 and plug it in right there. Is that right? $80 times 8,000 plus 225. Well, would that be right? Yeah, you could. And like this is another one of those that if you didn't have to use what we're doing in here, you would have probably figured this out, right? Yeah. But and the other thing is that a lot of times you're not going to use point slope for this because actually we already learned how you can use any point in the slope in slope intercept form. And so you're going to end up doing what we did like in the homework last night or on the quiz we just did. You know, and it's okay. Either one is okay. Either one will answer the question. I think what I've got left here, actually we got to do a little bit of standard form. Do I? No. Before I talk about standard form, I'm just going to talk a little bit about, I use point slope a lot. When I'm trying to convert one scale of grades to another, which happens sometimes, like for example, when we do AP testing, right? Or let's say if you're teaching an AP course, and I used to teach AP statistics. Do you know anything about AP tests? AP exams, advanced placement. Generally, they're on a scale of 1 to 5. 5 is the best. And if you get better, a 3 or better, most colleges will give you credit for that course in college, right? So that's why people like to take AP classes because it reduces what they've got to take in college. Now, in AP statistics, the minimum 5, which is the best grade you can get on it, is 63%. So now, if somebody got a 63 on my test, should I say they failed? They got the highest category, but so somehow I've got to take the AP scale and change it into the grading scale for, Tabb High School, right? Or else it wouldn't be fair. So actually, these are the cutoffs. 5 out of 5 is 63%. 4 out of 5 is 49%. You don't even get half right, and you get the second best score, right? 3 out of 5 is 37%, barely better than a third, and 2 out of 5 is 25%. So, what I would do is I would turn these into points. Let's say I need a scale, and obviously, I would still have to have like a 100%, 100% to have on the top of the scale. But I'm trying to think here. Yeah, because in the end, I'm not talking about 1 through 5. I'm just talking about the percent grades they got on my chapter test, right? So I'm trying to convert my chapter test because I understand it's hard material and they're not likely to get a 90. They're more likely to get in 60s or 70s. So I'm taking that scale. So there is actually a 100, 100 at the top, and there's a 0, 0 at the bottom. Those things are still on there. But then, let's say I needed to convert the grades that I think I'm going to say that anybody gets above a 63%, I think they should have an A. So I'm going to make that a 90. And anybody gets above a 49%, I'm going to say that's a B. So that gives me, well, actually the students score pretty low on these things, just like on the AP exam. So they need this kind of help. So here's the 2 points, right? If I just want to do the B range, the Bs go from 80% to 90%, then these would be my 2 points, 49, 80, and 63, 90. So I want to make a straight line equation between those 2 points. Do we know how to do that? Sure. Calculate the slope, plug it into either point slope or slope intercept form, and then there's your equation. Now, generally what I would do then is I would solve for y so that I can put it in my calculator here. Or I would use Excel. Does anybody ever use Excel as a program? Excel is like in the Microsoft Office, which has Word and PowerPoint and things. Excel is a spreadsheet. And so you can put formulas like that in the spreadsheet. So I just have the whole thing that converts all the grades that are likely much lower into the things that are more like what I want to put in the grade book, right? Now, what's going to happen is there's going to be a different line that connects these 2 points and these 2 points and these 2 points. So I have to do it like 5 times to come up with the entire 0 to 100. I think I have that on the next slide. If I just graph those points that I had on the last slide, it looks like this. So I have to make this line and then make this line and then make this line. In the end, I'll have 2, 3, 4, 5 equations. And I put them into Excel. Generally, I do it with Excel, but you can do it with that. So it's a very practical thing, and it doesn't have to be that you're a math teacher that you have a need to convert from one scale to another. So it's a useful thing to be able to do. I mean, another place where you might have to do that, which actually we end up having to do it, is in the SOLs, right? What's the best grade you can get on the SOLs? 600, right? The minimum pass advance is 500. Usually, if we have to turn SOLs into grades, and sometimes we do, sometimes we're told not to, but sometimes we do, then, usually you're going to use the 500 as the minimum A, right? And the 400, since that's the minimum passing, we'll call that the minimum D. So you're going to have to make a scale that goes from, 0 to 400, 400 to 500, and then 500 to 600. Make your equations so that you can convert the grades. I think I've got that. So if I just graph those points, 464 would be about right there. 590 is about right there. 600 and 100 is about right there. So I would have to make 2 equations. And I'm not even counting the less than 64. So again, calculate the slope. Let's say I use these 2 points to do this line right here. Then I'm going to say M equals 100 minus 90 divided by 600 minus 500, which is 10 over 100, which is 1/10. And then I plug it in, and I usually use point slope. That's the one I would use, but you could use the other. Y minus 90 equals 1/10 x minus 500. There we go. So it's useful. So if you're given data, 2 points or 1 point and the slope, then you could use the point slope form to start out, right? That's a good place to just like plug it in and get started. You could use slope intercept if you want, like we did in the homework last night. If you put it into point slope form, then you do have to solve for y. You want to have y as a function of x. So you can plug in on the right, calculate on the left. And then use the slope intercept form to do the calculations or graph it. Because again, calculator's looking for that y equals. But point slope form is useful because it's a good place to start. If you're just given, and most of the time you don't have the slope. Most of the time what you get is like 2 points. And you just want to make a linear relationship between the two. Now, is everything in life linear? No, everything in life is not linear. But you know what? Linear is like the 95% solution. Because even when things aren't quite linear, people will use a line to approximate what's going on in between 2 points. Now, there is another, the standard form we've already done, okay? And so we're not going to do a lot with this. Most of the homework is about the other. But remember, the standard form, ax plus by equals c, means the x term plus a y term equals a constant term. And it is useful almost exclusively to find x and y intercepts, right? Cover up one, solve for the other. Cover up one, solve for the other, right? Find the x and the y intercepts. Then it's very easy to graph. Besides that, I don't find a lot of use for it, but it is something we're supposed to be familiar with all three forms of a straight line. So these are the kind of problems they ask us to do here, which is write an equation in standard form of the line shown. Well, we can't just jump right to the standard form. You're going to have to do what we did already. Either, and it doesn't say, either use slope-intercept form like we did in the homework last night, or use point-slope form. But somewhere, use those 2 points to come up with the equation of a line, right? Which one do you want to do? Well, like we did in the homework last night, or point-slope? Point-slope, since we just did that. Okay, well, we can calculate, since it's a graph, what is the slope? From here to here. Right 1 and down 3. What does that make the slope? -3. -3 divided by +1, -3. Right? So from the graph, down 3, right 1. So m equals -3. Point slope, use one of those points. How about 1, 1? Y minus 1 equals m times x plus, I've got to fill that in. -3 times x minus 1. Okay, but it says put it in standard form. So you're not done. You've got to get the x and the y term on the left, the constant term on the right. So what should we do first? Which property should we use? Distributive. So we've got y minus 1 equals -3x plus 3. Okay, now we need the x term to be on the left and that -1 to be on the right. How can I make that happen? Miranda? Okay, let's plus 1 first to move that. Y equals -3x plus 4. And now we need the x term to go to the left. How do I do that? How do I cancel a -3x on the right? Add 3x, right? So add 3x to both sides. 3x plus y equals 4. Done. That's standard form. So if you're asked to put it in standard form, you have to start with either slope-intercept or point-slope and then do that. So try, I think there's one more you try. Is there? Try to do the same thing with that. What do you get for a slope?
2. -2. No, regular 2.
+2. Check your math if it wasn't +2. Remember, it's the -3 minus -1 is like -3 plus 1. That's -2. And 2 minus 3 is -1. So it's actually -2 divided by -1. And a negative over a negative is a positive. So you should have started with a +2. What you got? Yes. What is that?
That's a, wait,
What is the sign in between those two?
that's a y, that's a minus.
Is that a minus?
Should be a plus.
Yeah, that was a plus sign. Done. You get it? That's not right. So you used y plus 1 equals 2 times x minus 3, 2x. If you subtract 1, -6 minus -1 is -7. Other than that,
And I was doing the same thing, but like it says like x minus 2, how does it turn into x minus 1?
because 1/2 times 2 is 1. But
Okay.
you don't need to do, you're not trying to do that. Like you got to this point, which is good. Okay, no, that y, that's a 3 -1, right?
Oh.
And that's the y1. That goes here. The 3 goes there. Yeah. Yeah. My understanding is y plus 3 equals 2. That should have been x minus 2. That's not a -2. It's a +2. Why did you write? You wrote a negative. That should be x minus 2. So now that's 2x minus 4, and then subtract 3. And add the x to the other side. Okay, let's go over this. Quiet, please. So the slope was 2, right? There's the calculation. Everybody should have had the same slope. Now, what you did at this point kind of depends on whether you use 3 -1 or 2 -3. But I used 3 -1. Y minus -1 is y plus 1. 2 times x minus 3. Distribute, subtract 1 from both sides, add or subtract 2x from both sides, -2x plus y equals -7. In the end, that is, there's only one standard form. Everybody should get the same thing, whether you use 3 -1 or 2 -3. Well, there could be one difference. Did anybody get 2x minus y equals 7? It could be like all the signs are flipped, and that's okay too. I mean, what if at this point I subtracted, or even right here, what if I subtracted y over here and added 6 over here? Then everything would have opposite signs, but it's still the same. A lot of times when you're using standard form, they say that the leading coefficient should be positive, but not all the time. So we'll be okay with a -2x to be the leading term, even though it's negative. But if you wanted to change that, then just change everything. 2x minus y equals 7. Okay, one more skill. Write the equations of the lines. A horizontal and a vertical line, and you can see which points they're going through. What is the equation of the horizontal line that goes through 2, -4?
I can do that. Oh, I need a slope.
Remember, horizontal and vertical lines are x equals a number and y equals a number. You just have to figure out which one is the x equals and which one is the y equals. Agree? Just a second. What's that? No. X, in this point right here, right, which one is the x coordinate, which one is the y coordinate?
2 is the x, and
2 is the, so it's either x equals 2 or it's y equals negative 4. Which one is it?
How do you know which one? Negative 4 is 1.
Oh, I know. I think.
Oh,
Is
it's
this
X,
line x equals 2 or is it y equals negative 4?
Y is negative 4.
Y equals negative 4. A horizontal line. Remember, what's the y coordinate of every point on this line?
Oh, you're right.
Negative 4. So it's y, and this is the one which is x equals 4, right? Because a vertical line, the x coordinate is positive 4 for every point on that line, right? So when you have to write, if all you know is a point, you can come up with the equations for the horizontal and vertical lines. The blue line was our horizontal, so that one was y equals negative 4. The red line was vertical, so it's x equals 4. You know, both of those are standard form. That's why it's presented here, because that is standard form. The fact that there's not an x and a y term, that's okay. One of the two can be 0, right? One of the a or the b could be 0, but not both. So this is standard form. Actually, one of these is actually slope-intercept form too. Which one is slope-intercept? The blue line, because it's y equals, right? What is the slope? Remember, slope-intercept is mx plus b. What is that? Is it the mx or is it the b? It's the b. So what does that make m? Since you don't see an x, what did m have to equal? It was 0. And if, again, the slope of a horizontal line is 0. That's why you don't see the mx. It's 0, right? Because m is 0. That is not a slope-intercept form. It is standard form, but it's not slope-intercept form. And you cannot put that in the calculator because you don't have an x equals button. You just have a y equals button. Which one of those is not a function? The red line is not a function because it doesn't pass a vertical line test. Because a vertical line would intersect with a vertical line in infinitely in many places, so not a function. Okay, so let's see. Right, here's your you try. It should take you like 3 seconds. Write the equations of a horizontal and vertical lines that go through that point.
Horizontal. This is the X, right? This way. No, that's the Y. This is the Y. What?
Just write the equations. You don't even have to graph them. The horizontal line is?
9. Negative 9. Oh, wait.
It's got to have a variable in it.
Y. Wait.
Horizontal is?
Oh, the numbering.
Write the equation.
It's negative 9.
Equation has a variable in it.
Oh, so Y equals negative 9? I got it.
And then write the other one.
X equals negative 8.
Right? Again, x, y. Right? X equals negative 8. Y equals negative 9. Which one is horizontal?
The negative 9.
The y equals negative 9 is the horizontal. X equals negative 8 is the vertical. Right? Vertical. X equals negative 8. Horizontal. Y equals negative 9. Do it again. Write the horizontal and vertical lines that go through that point. And label them as such. Right? Which one is horizontal? Which one is vertical?
Y equals negative 5. X equals 13.
Okay, so x equals 13 is vertical. Y equals negative 5 is horizontal. Okay. Vert. X equals 13. Hors. Y equals negative 5.